Hello everyone. In this question, we'll be doing question number 70 on Leetcode, climbing stairs. This is part of our Blind 75 playlist on Leetcode where we go through the Blind 75 questions. So let's begin. So in this question, you are climbing a staircase. It takes n steps to reach the top, and at any time you can either climb one step or two steps. How many distinct ways can you climb to the top? So if you just think about this as a regular staircase, you might just skip two steps, or you might actually skip one step, or you might just not skip any steps, in which case you take a step, right? So if you just think about this, let's say this is the ground, right? Ground. And then you have step number one. How do I do it? Let's just say this is the step. And then you finally have step number two, right? Something like this. And then you can keep going. So this will be step number three. So basically at the ground over here, you can either take one step or you could take two steps by skipping this first step over here. And we want to figure out how many ways can we reach the nth step, the step over here. Well, if you think about this, the amount of ways that we can reach this step over here is dependent on the amount of ways we can reach this step and the amount of ways we can reach this step. Why? Because if we figure out the amount of ways we can reach this step, well then we just need to add, well, one step, right? Like from here, we just need to take one more step. Similarly, if we figure out the amount of ways we can reach this step, well, if we reach here, then all we need to do is we can basically just take two steps, or we skip this first step here, and we arrive at the top here. So basically this question, all it boils down to is figuring out what are the amount of ways we can figure out, or we can reach this step over here, and then we can just take one step after that, or the amount of steps we can take to reach this step, and then we take two steps to reach the top here. Or I guess like you skip one here, and that's why you take the second one here. So you might actually think of this in terms of recursion, and maybe that's a good place to start. So let's start off with a recursive approach. So with recursion, I always like to have a helper function. And here, all I really need is just n, right? I need to know which step I'm trying to reach at. So let's create our helper method here for recursion, right? Now, as with recursion, we need our base cases, right? So what are our base cases? Well, luckily, we're kind of given them here, right? So what if n is equal to 1? Like, what if there's only one step? Well, if there's only one step, there's only one way we can reach it, right? By taking that single step. So if this didn't exist, if this did not exist, then the only way you could reach here is by taking a single step, right? So the answer of this would be 1. What if n is equal to 2? Well, if n is equal to 2, then we have something like this. We can either take one step and one step, or we can directly take one step to the top. So the amount of ways you can do this is 2. Now, otherwise, if n is greater than 2, then all we need to do is we need to figure out what are the amount of ways we can reach the previous step, plus what are the amount of ways we can reach the second previous step. And basically, just by doing this, we have solved the question, at least in terms of a recursive approach, right? So let's go ahead and submit this. Now, this one is actually the correct answer, but obviously it's horribly inefficient, right? You're using recursion here on a question that you don't really need to be using it in. So what is kind of the next step here? Well, you could technically do memoization, and memoization is basically the process of caching your recursive results, right? Because if you were to draw the tree here, you're technically calculating a lot of this again and again that you don't need to. So how about we introduce memoization? And luckily, it's very easy in Python. Basically, all you need is a dictionary. You need a memo variable. Now, basically here, we will cache these results. So memo at n, which is memo at 1, is basically equal to 1, and then we'll just return memo at n. Right? Memo at 2, which is memo at n, is equal to 2, and then we'll just return memo at n. We'll also check if memo at n exists, right? So if n in memo, then we just return memo at n, right? Otherwise, what we can do is we can recurse, and we'll store this in memo at n, and then in the end, we'll just return memo at n, right? So this is another way in which it can work. So here, we'll just run this. And you can see here that I need to pass in memo. That's why this was failing. Let's pass this in. Actually, I realized that we don't really need to return memo here, because once this is set, then this will be true, right? So now we can also just do test 44 we failed on previously to see if it passes. Okay, so it passes. It's faster, but it's not too fast. So, okay, that is too fast. But like, the kind of the way you want to do this is without any sort of variable like this, without any sort of cache like this. So we'll just use dynamic programming. So in dynamic programming, basically our idea is going to be the same, right? So here we'll basically have an array. And so what is our array going to be? So our array will be a list, and we can just set it to 0. And this will be of size n, right? It'll be of size n. Now, what do we know about our array? Well, we know that array at 0, or actually, if we want to kind of follow this approach here, it might make more sense to create this n plus 1, and then actually start off at array of 1 is equal to 1, array of 2 is equal to 2. So here we are just setting our base cases here, right? And then what we can actually do is we can actually check if n is equal to 1, let's just return 1. If n is equal to 2, let's return 2. Otherwise, we set this array over here. And now basically all we need to do is we need to figure out like what is going to be, we need to fill out this array essentially. So we can fill it out by index 3, and we will go to length of array, right? And so what is array at I? Array at I is basically array at I minus 1 plus array at I minus 2, right? And then once this entire array is filled out, we can just return array at n. And this one should give the right answer. So let's go ahead and run this. You can see it returns true. And then we'll just run this here. And you can see it also returns true. So I just want to introduce like the memoization here as well. Obviously, you wouldn't use it and you would just go directly for dynamic programming, but sometimes it helps to go for the memoization approach first so you can easily follow and see what the dynamic programming one would be. Okay, yeah, so that's all there is for this question.